So a right angle triangle, let me just draw it here. So consider this right angled triangle. So let's say, name the side there A, we'll name this side B, and that side C. Now, let's say, get back to Pythagoras theorem. So if you consider Pythagoras theorem, so Pythagoras theorem tells us the following. So in this case, Pythagoras theorem says that A squared plus B squared is equal to C squared. So that's what we have from Pythagoras theorem. Now, let's consider the angle theta. So, from the angle theta, what we also know are the trigonometric ratios. So the trigonometric ratios that we have are the following. So we have sine theta is equal to opposite, which is A, over hypotenuse, which is C. Also, the cosine of theta is equal to adjacent, which is B, over hypotenuse, which is C. Right, so those are the trigonometric ratios. Of course, we can think of the tangent, and the tangent here is just the opposite, which is A, over adjacent, which is B. So those are the ratios that we get from the triangle that we have. So now, what we are going to do is for us to be able to substitute what we have as trigonometric functions in the Pythagoras theorem. Okay, so coming back to Pythagoras theorem, let's square the following. So we have, let me write it here, sine squared theta plus the cosine theta. So let's square and add. So from the trigonometric ratios, what we have is A over C whole squared plus B over C whole squared. So this is what we get. Is someone trying to say something? Please mute your mic if you are not saying anything. Right, so this now gives us the following. So you have A squared over C squared plus B squared over C squared, which gives us A squared plus B squared over C squared. So, but what we know from Pythagoras theorem is that A squared plus B squared is C squared. So in this case, then what we are going to see is that this is C squared divided by C squared. And of course, C squared divided by C squared, this gives us 1. So what we are saying then is the following. So that's the first identity that we are going to get. Yes, please. What is a squared plus b squared from here? Yeah. Any other question or clarification? Right, so I was saying that this gives us a first identity. So the first identity is the following. So you have sine squared theta plus the cosine squared theta is equal to 1. So this is the first identity. It is a basic identity of trigonometric functions, of course. And this identity is important because we can get many other identities from this one. Is someone trying to ask a question? Right, so the next identity, of course, that we can get is just a question of rewriting the identity number 1 as follows. So identity number 2 will just be sine squared theta is equal to 1 minus the cosine squared theta. So that is the second identity. Last one, I can see your hand. Can you go ahead and ask a question if you have a question? Okay, so it is quiet. We can also get the third identity, and the third identity is the following. The cosine squared of theta is equal to 1 minus sine squared theta. Right, so these are the three identities that we can think about from just the first identity. So remember that I said the first identity gives us other identities. So far we have two identities. Now, I just want you to note the following.
Sorry to disturb, sir.
Yes, please.
Some of us joined from Google Meet, and it wasn't what this. You didn't start teaching from Google Meet, so most of the people are there.
Oh, is that so?
Yeah. Yes.
How come I'm not teaching at Google Meet? Can people hear me from Google Meet? Because I can see
No,
the
there's
screen is
nothing.
there.
It wasn't. We joined like at 16 hours, and there was nothing happening.
Oh, okay. But now there's something that is happening. You can see what is going on, right?
No, I left Google Meet, then I joined Zoom, so I don't know about the people who remain that side.
Yeah, sorry, I'm asking those on Google Meet. I hear someone saying everything is okay, isn't it? Okay. Okay, so there's just one thing that I want you to know, probably you have noticed. So when we say sine squared theta, what we are saying is this is sine theta squared. So the notation that we use is that one. So it is sine theta squared, which is just the sine theta times sine theta. Right, so that's that particular notation, so we know what we are talking about. Okay, so we can move to the next identity. So I want to go to the next board. So in doing that, I will erase whatever is on this one so that we can see what's going on. Right, so the fourth identity, first of all, I'll still rewrite the first identity as the sine squared theta plus the cosine squared theta is equal to 1. So this is the first identity. Now, let's divide. So divide the first identity by cos squared theta. So when we do that, what we are going to get is the following. So you have sine squared theta divided by cos squared theta plus cos squared theta divided by cos squared theta is equal to 1 divided by cos squared theta. So this is what we see. And so in this case, what we are going to get, we know sine over cos is the same as the tangent. So this is the tangent squared of theta, and that cos squared theta divided by cos squared theta is equal to 1. And then 1 over cos, this is the secondary trigonometric function. So 1 over cos, you remember that it was the sec of theta. So that's what we are going to get. And actually, this turns out to be our fourth identity. So from the first identity, we have the second one, the third one, and also the fourth identity. If we go ahead and divide 1 by sine squared theta, so what we get is the following. So you have sine squared theta divided by sine squared theta, and then plus cos squared theta divided by sine squared theta. This is equal to 1 over sine squared theta. So again, by dividing the first identity, that's what we are going to get. And this gives us the fifth identity. So the fifth identity now is here you get 1, then plus the cosine over sine. We know that this is just 1 over tan. So this is the cot squared theta. And then the other side, the right-hand side, you have 1 over sine, which is the cosec. So that is the cosec squared theta. Right, so this gives us the fifth identity. So you can see that from just the first identity, we can rewrite it in different ways, and it gives us different identities. Is there any question so far or clarification? Yes. Sorry? It's a function, it's a trigonometric function. So remember that I gave you the primary trigonometric functions, then we had the secondary trigonometric functions. Did you attend the first lecture on trigonometry? Okay, so I said yes, K Kushwa, whatever that name is.
Sir.
Yes?
Sir.
Yes?
I have a question. Is that 5.1? Is that 5.1?
No, it's not 5.1. It is just 5.
Oh, it's just 5.
So it's a number 5. So this is now 1, which is the sine over sine.
Oh, okay.
Yes. Yes, please. So in which identity? The fourth identity or the fifth identity? The third. Okay. Right. So let me first of all answer the first question. So that one asked about cosec. I'm giving you the definition of what those are. So 1 over sine theta is the cosec of theta. 1 over cos theta is the sec of theta, and 1 over the tangent of theta is the cot theta. So that's how we define those second trigonometric functions. I hope that helps you. So of course, when you square, then everything else, of course, is squared. Okay. Now, somebody was asking about the note that I wrote was this sine squared theta. This by notation is sine theta squared, which I wrote as the sine theta times sine theta. So what clarity do you need on this one? Because that's the note I remember writing. Is it this one? But remember here that we are dividing the equation number 1, this one, by cos squared theta. So I've just divided the first term, the second term, and the third term. Just divide. Do you see that? Yes, so I've just divided. I haven't changed anything. It's the same thing I've done here. We are also dividing by sine, this same equation that we have here. So just divide through by sine. Okay. I hope everything is clear. Now I want to give you an example, but I'll have to use the next board for us to be able to do this example. So let's bear in mind the identities, the 5 identities that we have so far. Apparently, you need to know these identities and be able to use them whenever you have to. I don't encourage memorizing, but you can memorize and know. Right, so let's look at the following example. So let's verify the identities. So the first is the following, verify. So let me just write a general sentence and then the others will follow. So they verify the identity. So the identity is the following. We have sine theta divided by, we want to use what we know or what we have seen before for us to be able to do the verification. Right, so here is the solution. So to verify something, you must show that the left-hand side is equal to the right-hand side. So you start with either the left-hand side and get the right-hand side, or you start with the right-hand side and get the left-hand side. So now, let's see what we have from the left-hand side. So the left-hand side, we have the sine of theta divided by cosec theta, plus cos theta divided by sec theta. Right, so what do we know about sec theta and the cosec of theta? So we see that this is going to be equal to sine theta divided by cosec theta. So cosec theta is 1 over sine theta. So that's what we know by definition. And then you have cos theta divided by sec theta. Sec theta is 1 over the cosine of theta. So now you can see that this just gives us sine squared theta plus the cosine squared theta. And so this is an identity. Sine squared theta plus cos squared theta is equal to 1, which gives us the right-hand side. So this is how you verify the identities. You just need to use the identity or an appropriate identity that we have seen, and also the definitions of the secondary trigonometric functions. Is there any question on this one? Is this okay, or is this clear, or is there anything that we can clarify? Okay. If there is nothing, then we can go to second example. The second example is we verify that cos x plus cos x times the tangent of x squared, this should be equal to the sec of x. So we want to verify this identity. So like I said, depending on how the identity is given, you can choose to start from the right and get to the left, or start from the left and get to the right. Is there any question? Someone wants to say something? Go ahead, please.
Yes, sir. Is there a plus between cos x and tan squared there?
No, there isn't. It's a multiplication. So I haven't put the brackets, so we are multiplying. Any other clarification? Right, so let's try to solve this. Again, I'll start from the left-hand side. So the left-hand side has the cosine of x plus cos x times the tangent of x. So what we have, so this is tan squared. Right, so we have identities that link the tan squared. And so in this case, first of all, before I go further, we can see that the cosine of x is actually common to both terms. So we can factorize this and get 1 plus the tangent of x squared. Okay, so then what do we have? This is an identity which we saw earlier. And so we just replace 1 plus tan squared theta by that particular identity. What identity is that? Can someone tell me?
Come again.
So what identity is this? We have 1 plus tan squared x. Do we have such an identity?
Yes, it's the fourth one.
So it is identity number 4. So identity number 4 says that tan squared theta plus 1 is equal to sec squared theta. So that is our fourth identity. So what we have is this. So we are just going to substitute with the sec squared theta. So in that case, you are going to have cos x times sec squared x. Okay, so remember that we want to get to the right-hand side. So we can use the definition of sec squared x. So sec squared, we know that 1 over cos is sec. So in that case, you are going to get 1 over cos squared x, sorry, not theta. So it's 1 over cos squared x. So that is what we have. And so now you can see that this will just be 1 over cos x. Because now we can divide cos there and 1 cos here to remain with 1 over cos. And so 1 over cos is actually sec x. And you can see that this is what is on the right-hand side. Right, so we have verified this identity by showing that the left-hand side is equal to the right-hand side. I guess the idea is becoming clear. Is there any question before I proceed to the next example? Okay. So we move to the next example. Again, I will just delete what is here so that we can use the same board. So here is the third example. Let's verify that 1 over sec squared theta is equal to 1 plus sine theta times 1 minus sine theta. Right, so this is the identity that we are going to verify. Now remember that it doesn't matter whether you start from the left and show the right-hand side, or you start from the right and show the left-hand side. So in this case, I will start from the right. So the right-hand side has 1 plus sine theta. And by the way, you decide whether to start from the right or the left, depending on how the identity is given to you. So for me, I find it easier to expand here and see if there's an identity that we can use for us to be able to solve this. Okay, so if you look at what we have, you will see that this is a difference of 2 squares. Okay, so it is a difference of 2 squares, which is just 1 minus, or rather 1 plus a times 1 minus a. So you have a difference of 2 squares, and we know how to deal with a difference of 2 squares. So that gives us 1 and then minus sine squared theta. Okay, so in case you forgot that it was a difference of 2 squares, you can actually go ahead and expand. So you have 1 times 1, which gives you 1. The next is 1 times negative sine theta, which gives you negative sine theta. And then next you have sine theta times 1, which is sine theta. So you see that you have a negative sine theta and sine theta, which cancels. And then the last term is sine squared theta, because you have sine theta times sine theta. Right, so this is an identity. What do you get? 1 minus sine squared theta.
So is it not cos squared theta?
Yes, so you get cos squared theta in that case, which is identity number 3. So that is the cosine squared theta. Okay. Now, the cosine squared theta, if you look at what we have, we need 1 over sec squared theta. And you know what sec is. So being clever here, of course, you need to think. I'll write this as follows. So this is 1 divided by 1 over cos squared theta. So I have not changed anything here. If you can see what we have, because this still comes back as cos squared theta. So I've written this because I know what I want to get at the end of the day, which is that term. So for me to get sec squared theta, I must have 1 over cos squared theta. So this is now what gives me 1 over sec squared theta, which is the left-hand side. Okay. So that's how you can go about it. But of course, you can also start from the left-hand side. So you can see, if you are starting from the left-hand side, then you can rewrite this term in that way. So you just divide by the cosine of theta, and then you know that what you have here is just the cos squared theta, and then you bring in that identity 3, which we looked at. Cos squared theta is equal to 1 minus sine squared theta, and you have to think that this is a difference of 2 squares, so you can write it in that particular way. So whether you start from the left to show the right-hand side or start from the right and show the left-hand side, it does not matter. Is there any question?
So, sir, can you start from both sides?
Of course, you can
To solve
start
the-
from both sides. Now, you have to start from one side, of course, because you can't do both sides at the same time. So, by both sides, what I mean is, in case you are stuck here, for instance, you don't know how to proceed when you reach this stage, then you can stop there and then start from the other side and see if you can reach that particular stage. So if you reach here from the left, then you can conclude that the left-hand side and the right-hand side are the same. I hope that is what you were asking.
All right, thank you, sir. Yes, sir.
Okay, any other question?
Yes, sir. On one minus sine theta there, can we, instead of doing the difference of two squares, is it okay to inject the cos squared theta there?
Well, I'm not sure now where. So instead of 1 minus sine squared theta, is it okay
Yes,
to do what?
to inject the identity of that is cos squared theta. I don't know if they match here.
Is it not this one which we have here?
Okay.
So we have used that identity you have. 1 minus sine squared theta is the cosine squared of theta.
Sorry, sir. Okay, it's okay.
Okay. Yes, any other question?
How is 1 over 1 cos theta squared equal to 1 over sec squared?
Come again with a question, speak up a bit.
For the last example we're doing,
Yes.
how is the left hand side equal to the right hand side when the right hand side is 1 over theta squared?
So the left-hand side is what we have here from our question, which is this one. So the left-hand side is 1 over sec squared theta. And the right-hand side is what we have there. So if you have followed, what we are saying is that we can start from the right-hand side, which is what I've written here, expand, and use the identity for us to be able to get to the left-hand side. So you can see that at this stage, when we have 1 over cos squared theta, what I wanted was the left-hand side, which has a sec squared theta. And I know how to get sec squared theta. It is this. So that is how I've written it. And I was saying that 1 over cos squared theta is the same as cos squared theta. So because we have gotten the right-hand side, or rather the left-hand side, then we can conclude that the left and the right are the same. Does that answer your question, or there's still something that I'm missing?
No, it does.
Okay. Right, so we have cos x plus tan x divided by cos x, rather, times sine x. And this should be equal to the cosec of x plus sec squared x. Right, so we want to verify this identity. Again, where you start from may not matter here. You just need to think along the way what to do in order for you to use particular identities. Like someone had already suggested earlier, you can start from the left, and if you can't proceed, stop there, go to the right, and see if you can get where you stopped from the left. Right, so here is how we are going to go about this one. Let me so I'll start from the left. So from the left-hand side. So the left-hand side is the cosine of x plus the tangent of x divided by sine x times the cosine of x. Right, so we'll start from what we know. So we have the cosine of x. The tangent, we know we can write it in terms of sine and cos. So I'll write this as sine x divided by the cosine of x, and everything is divided by sine x and the cosine of x. So this is what we have. The next thing, whenever we have fractions, let's try to write it as one fraction by finding the common denominator. So if the common denominator is the cosine of x, so I'll write the common denominator as the cosine of x. So in this case, then here we will have the cosine squared of x plus sine x. So that is in the numerator. And our denominator, of course, remains as the cos x times sine x. So the order here doesn't matter. Right, so when we have a common denominator, of course, we know that we can rewrite this as the cos squared x plus the sine x divided by cos squared x sine x. Is there any question so far? So again, I'm just using what we know. Now, let's look at this as follows. So we have a fraction or a sum in the numerator, which has cos squared x. So let's divide this by, we separate the fractions. So that will be divided by cos squared x and sine x. And then the other term is the sine x divided by cos squared x sine x. Right. So we see now that what we have here, if we divide, we remain with 1 over sine x in the first term. So we divide that and that. Here we also divide sine x. So you see that what we remain with is just 1 over cos squared x. Right, so 1 over sine x, we know that this is the sec x. So that gives us the, cosec x. So you get cosec x. And then the other one, which is 1 over sine, or rather cosine squared, is just the sec squared x. Okay, so you can see that this is what we have as the right-hand side. So that's what we wanted to get. So we have verified that the left-hand side is equal to the right-hand side in this particular situation. Is there any question? So again, you just need to know those identities and think a little on how you can rewrite the functions that you are given, in which will lead you to a particular identity. So
Yes,
in
sir.
English, they say practice makes perfect. In mathematics, that is true. As you practice, then you will be able to know this. Yes. Ask the question.
The last part, is it cosec x plus sec squared?
Yes.
Okay.
Okay. So let me give you another example. So this I'll call it example number 5. Up a bit. Right, so let's say do the following. If sine theta is equal to 3/5, and the cosine of theta is less than 0. Let's find the values. So let's find the values of the other trigonometric functions. Right, so we find the values of the other trigonometric functions. So we have the sine, we need to find the cosine of theta, we need to find the tangent of theta, and then we can get the other, the cosecant, the secant, and the cot. But I'll just focus on the 3, the sine, the cosine, and the tangent. Now, there are many ways, or there are different ways in which you can solve this. So you find those ways later. But I will show you how to go about this using the identity. So let's use the first identity. The first identity says that 1 is equal to the cosine of theta squared plus the sine of theta squared. So that is the first identity. Of course, I know sine theta, so I know I can get the cosine of theta from what we have here. So this then implies the following. So 1 will be equal to the cosine squared of theta plus, we know sine theta, so that will be 3/5 all squared. Okay, so this then implies that the cosine squared of theta will be equal to 1 minus 9/25. I hope everyone is following up to this. But then what is 1 minus 9 over 25? So the cosine squared of theta will be equal to 25 minus 9 over 25. And 25 minus 9 will be 16 over 25. Right, so here then, what it implies, therefore, is that the cosine the cosine of theta, so the cosine of theta will be equal to the square root of 16 divided by 25. So you see that this is plus or minus 4 over 5. Okay. Now, we know that we are told rather that the cosine of theta is less than 0. So I'll just say, since the cosine of theta is less than 0, then what we are interested in is that cos theta should be equal to the negative of 4 over 5. So that's how we can solve this particular problem. So the first trigonometric function that we got now is that the cosine of theta is equal to the negative of 4 over 5. Is there any question? Right, so if we have the cosine and the sine, then we can actually get the tangent. So the tangent is sine theta divided by the cosine of theta. And so we can see that this is so sine theta is given as 3 over 5 divided by the cosine of theta, which is negative 4 over 5. And we can see that this just gives us negative 3 over 4. Right, so those are the other trigonometric functions. Now you can get the rest, which are the cotangent, the secant, and the cosec, by just getting the reciprocal of the 3 that we have found. All right, is there any question? Yes, please go ahead.
So I'm not sure me on how you got negative 3 over 4.
Divide 3 over 5 by negative 4 over 5. Then you see that we get negative 3 over 4. Or is it 3 over negative 4? That is the same. Is that okay? We still need the more.
It's okay. Okay.
All right. Yes. Yes. Okay. Right, so he's saying that we have to think of this angle in the right-angled triangle, which is a good suggestion, of course. And we say that the opposite is 3 and the hypotenuse is 5. Okay, so that is 3 and that is 5. And then we can use the Pythagoras theorem for us to be able to find this side, which I can call B. And then once we have that side, then we have all the trigonometric ratios that we are looking for. That is fine. But then you need to also think of what we have been told here to say that the cosine of this angle is less than 0. So you need to know in which quadrants your triangle will be drawn. Okay. So for instance, in this case, in which quadrant is the cosine negative? Can someone quickly tell me?
Is it not second?
In the second quadrant? That's all?
And in the third,
And in the
and
third
in the third
quadrant.
yes.
Okay. So it is in the second and in the third quadrant. So this is now what you just need to do. All you need is just, of course, if you say 5 squared minus 3 squared, this gives you b squared. So you have 25 minus 9 is b squared, which implies that 16 is equal to b squared, and b squared will be equal to plus or minus 4. Okay, so because you are in the quadrants where the cosine is negative, of course, you always think of the negative part of 4. So that even when you are writing your angles now, the cosine of theta, it will be negative 4 over 5. So as long as you know where you are, then there is no problem. You can still use this method. Is that clear? All right. So if there's no question, I think we can end here for today. And let's see, there's one more clarification. I have less than 1 minute on Zoom.